Alright, so we just learned about how they used to graph back in the day and what zeros did, what multiplicities did, what turning points did, and everything. So what we're going to talk about today is how to solve polynomial equations. Okay, and there's going to be a couple new things that we need to go over. So first off, I'm going to go to, boom, there we go, factoring flowchart, so that you guys can see what we are talking about. So let me go back to the first page. There we go. Okay, so factoring flowchart. All right, let me move the screen over a little bit. Okay, so the factoring flowchart is just the methods you're going to use to actually find out how to factor, because one of the methods is factoring, and it's going to be one of the many methods we use. Okay, so the first thing you always look for is greatest common factor. If you have none, you go next to how many terms. If there is a greatest common factor, you factor that out, and that's going to be part of your answer, so don't forget about that. Okay, then you go to how many terms. All right, now if you have 2, 3, or 4, you're going to be doing different paths. If you have 4 or more, you're probably going to be factoring by grouping, like what you did in Algebra 1. If you have 2, you're going to be doing it one of 2 ways. Is it a difference of squares? Now, if it's a difference of squares, it's going to be really easy to factor in that you can go a squared minus b squared equals a plus b times a minus b, and that's it. You just move on from there, and then you solve by solutions, and I'll show you later. Okay, if you do not have a difference of perfect squares, you need to ask yourself more questions. Now, difference of perfect squares is where it has a minus sign in between, and these are both squares, like x squared and 16, or x to the 4th, and 25, or 400, whatever you want. Just some perfect square number. Okay, now if you have a sum of squares, you cannot factor it. So you need to use a different method, and I'll show you that later. All right, now if it's a sum or difference of cubes, here's how it works. Sum or difference of cubes is where you have a perfect cube plus a perfect cube. You can factor that into the cube root of the first number plus the cube root of the second number times the square root of the first number, if you were to break it down into its one term that is multiplied 3 times, minus a times b plus b squared. And I'll show you how to factor it a little bit later with an example. Okay, now this one is minus, so this is a difference of perfect cubes. Now the cool thing is that I can do either one. I can factor it still. Okay, so this turns into a minus b, and then a squared plus ab plus b squared. Okay, now here's the cool thing. If this first sign is a plus, this first sign is going to be plus. So that's nice. If this first sign right here is a negative, this first sign here is going to be negative. And then the subsequent term, or the subsequent sign, is going to be the opposite of what you started with. And then the last term is always going to be positive. So we'll come back and factor some stuff out like that first. Now back to 3 terms. Okay, now if it's 3 terms, it's going to be a perfect square trinomial. If it is, you can just easily go a squared plus or minus 2ab plus b squared. So if it's like x squared plus 4x plus 4, it's going to become x plus 4 squared. Okay, something simple like that. If it's not, you're going to look at the coefficients of the first terms. So if it is, you just factor the easy way. You go, okay, I get 2 numbers. To get these 2 numbers, I need to ask myself, what 2 numbers add up to b, but multiply to get to c? Okay, and once I get those 2 numbers, I can factor it into 2 binomials. Now, if not, you would use factor using the long AC method way. Okay, and we'll talk more about that later, but for right now, we're not going to bring that up as much. Okay, so let's go back to the actual problem at hand. Okay, so difference of perfect cubes. So let me give you a quick example. So let's say we had x cubed minus 27. Okay, so to factor that, I would have x minus 3. I would cube root each. And then I would have x squared plus 3x plus 9. Notice I don't have the 2 in there. Normally when I was doing like a difference of perfect squares, I would go 2 times 3x and then get like 6x and stuff. I'm not going to do that with difference or sum of perfect cubes. Okay. All right, let's say we had something like this. 8 minus y to the third. Okay, now if I had something like this where I reverse the order, once again, just reverse the order. So this is going to be 2, well, shoot, let's make this a positive, just so you see an example of both. Let's go plus. Okay. All right, there we go. Okay, so this is going to be 2 minus y. Well, it's going to be 2 plus y. Jeez, I forgot my own little special rule. The next sign is always going to be subsequently, then it's going to be the same. And then I'm going to have 4 minus 2y plus y cubed. Okay? Or not y cubed, y squared. All right, and that's how you do a factoring of a difference of perfect cubes or squares. Okay? So I'm going to look at some examples in the book to show you what I'm expecting of you guys. Okay, and you can take any type of example from this. Okay, so first off, I go 2x to the third minus 5x to the second equals 3x. Now how do I solve this for x? First off, I have to get in standard form. So I'm going to move the 3x over to the other side. So it's going to be 2x cubed minus 5x squared minus 3x equals 0. Okay, so first thing I'm going to notice is, oh, I can factor out an x, so I do. So now I have 2x squared minus 5x minus 3 equals 0. Okay, and then I'm going to notice, oh man, I have to do the long way because why? That first number is not 1. Okay, so I'm going to factor out the long way. Now I'm going to kind of forget about the x for now. I'm just going to leave it in limbo and stuff, but I'm going to factor the next part. So I'm going to go, let me see, it's x squared. I do the AC method, so I take the 2 times the negative 3 and get negative 6. So x squared minus 5x minus 6. Okay, and then I go ahead and factor that. So it'd be x minus 2, x minus 3. Okay, now if you remember in the AC method that we've talked about before, I'm going to take this 2 and put it back in. So it becomes 2x minus 2 and then 2x minus 3. Okay, and then I'm going to recognize, oh, I can factor out a 2 out of here, so I'm going to factor out a 2 and just get rid of it. Okay, so I'm going to bring back the x that was in limbo before. I'm going to have x minus 1 here and 2x minus 3. Okay. Now if I was uncertain about my work, I would go back and just do FOIL and just distribute and do all kinds of stuff to figure that out. Okay, so now that I have this, I set up each part because this is the fundamental, this is the factor theorem right here. You can set up each part equal to 0. So x equals 0, or x minus 1 equals 0, or 2x minus 3 equals 0. Okay, and then I solve each one. This one's already been done, so I know that one of my factors is one of my answers is going to be 0. This one's pretty easy. It's going to be x equals 1, so that's another answer. This one's not going to be as easy. It's going to be 2x equals 3, and then I can divide both sides by 2, so x should be 3 halves. Okay, so now I have my 3 answers. Now if you wanted to see if that was truly the answers, you would take each one of these and plug them into each situation and see that you get the same number on each side. And trust me, you do. It happens. Okay, so that's how we solve those. That's how we solve a polynomial function using factors. Okay, now sometimes you may need to, if you can't factor, so let me write this disclaimer out. If you can't factor, use quadratic formula. Okay, now that's only when you're trying to work with a quadratic. Okay, if you're using with a quadric or a cubic or a quintic type of function, you can't use that until you get down to quadratic, and you'll see how to work it down in the future. Okay. All right, now just by factoring and stuff, just by looking at all this stuff, guys, you just have to realize that sometimes you might be given something that doesn't look like you should be doing it. So like x to the fourth minus 3x squared equals 4. Okay, you have to move the 4 over, and this is going to be x to the fourth minus 3x squared minus 4 equals 0. Now this one, a lot of people have trouble with, is they have to recognize that that is actually, you can factor this. You're just going to have x squares instead of the usual just x. So this is going to be x, let's go, let me see, what two numbers multiply to 4 but add up, negative 4 but add up to negative 3? I think it would be negative 4 comma, okay, so I've got to write it out properly. That's another important thing of working this out. And x squared minus 1. Okay. All right, so now that I do that, if you notice when I get done factoring, I can still factor. I want to keep going until I get to just single degrees of 1. So I can factor that. That's a difference of perfect squares. That's x minus 2, x plus 2, and this turns into an x minus 1 and an x plus 1. Okay, so I went from what supposedly was 2 answers to what was actually 4 answers. And I get x to be 2, negative 2, negative 1, 1. Okay, and I can find all those answers. Now, if I wanted to actually graph and see what my answers are going to be, hold on one sec. Okay, so what I would do is I would take a look at this bad boy right here. Okay. All right, now I would graph it just to check. Now, if you notice, when I graph it, I get just 2 answers. I get negative 2 and 2. So what happened to the other one? Okay. Well, I go back to my work, and I look at it, and I'm going, blah, blah, blah. Wait, hold on. Look at my factoring. Negative 4 times negative 1 is not negative 4. This needs to be positive. So that's interesting. So that's actually not worked out this way. So this just stays as x squared plus 1. Okay? So that's really interesting in itself. So how do we get the rest? What you could do is each one of these ones right here, you just set equal to 0. That makes sense. Do the same thing here. Okay? All right, so what I'm going to do is I'm going to get rid of these 1s and negative 1s because I know my graph is not saying the same picture. Because if it was, I would actually have this graph cross at negative 1 and 1. But I'm not, so that's an issue. So what I'm going to do is I'm going to solve it by setting it equal to 0. So x squared equals, or x squared plus 1 equals 0. Okay, so I'm going minus 1 to both sides, so x squared equals negative 1. And guess what? You have to square root it. And what happens when you square root a negative? Well, first off, you're going to get a plus or minus answer. So x equals alt 241 plus or minus I. So that's going to be my other answers, I and negative I. Okay, and that's how you get your answers, both real and imaginary. So it's really kind of cool how it works. You do have to be ready for that, and just understand is that when you're graphing, it's going to be really easy to just go through it and stuff. But here's the thing, graphing is very nice, however, it does not give you all the answers. It will give you your real answers, but not your imaginary. So you can at least start it out and know, okay, I'm on the right track, I have the right thing, I just need to figure it out. Now, if these cross at 1 and negative 1, I wouldn't have the I and the negative I. Okay. All right, that's it for today, and I will talk to you more about division next. Bye.